Why does it look like the two red lines get closer together the farther away you look? Objects that are farther away from us look smaller to us, and the ends of the red lines are much farther away, about 100 feet farther away than the beginning of the lines. So the distance between the end of the lines looks smaller to us than the distance between the beginning of the lines. So it looks like the lines are getting closer together. If you were an architect, you would say that the lines are in perspective. The projected plane is similar to the usual flat plane, except that we add an extra point in each direction that is infinitely far away, called a point at infinity. And the red lines in front of you can help us understand more about what the motivation for adding these mysterious points at infinity is. Imagine you stand at the beginning of the red lines and they continue on forever into the distance. What can you say about the appearance of the closeness of the lines? The lines will appear to get closer and closer together, so if we drew them for an infinite amount of time, it is fair to say that they will look like they intersected. Since any two parallel lines point in the exact same direction, they will have the same point at infinity. And this is exactly what the point at infinity is trying to tell us, that any two parallel lines look like they intersect infinitely far away, or that two parallel lines intersect at the point at infinity. Admittedly, mathematics is often extremely abstracted from the real world, and you would think the same if you learned about projective geometry in a math classroom. And while math can be so powerful and beautiful because it is so general, we often forget that it is weaved into our world in an uncanny way. And it isn't just projective geometry. Special sequences of numbers and specific ratios appear consistently in nature, like the Fibonacci numbers and the golden ratio. A space that's called the hyperbolic plane with a really weird notion of distance describes how planets orbit. And one of the most abstract branches of math that only serves to describe the structure of other abstract branches of math can model chemical equations and agent interaction in economics. A lot of the time, math is developed by a mathematician sitting in a room, and then years later, physicists, chemists, or biologists will find a way that the math describes their theories incredibly well. Mathematics is entwined in our physical world, and intuition and explanation for incredibly abstract concepts like that of the projective plane are often hiding in plain sight, if we just remember to look.